Okay, so we're talking engine lubrication today. Keeping those parts moving smooth, you know?
Yeah. Lubrication is key, man.
I bet you already know oil reduces friction, but let's get into the real nitty-gritty.
Yeah, let's do it. This stuff even some seasoned mechanics might not know.
All right, so I think a lot of folks don't even realize there are different types of friction happening inside an engine. It's not just like parts rubbing together.
That's right. You got sliding friction, like your piston rings on the cylinder walls.
Uh-huh.
You got rolling friction in the bearings. And then you got wiping friction.
Wiping.
Yeah, like when surfaces are moving back and forth across each other.
Okay, so how do bearings actually reduce all that friction? I mean, it's metal on metal, right?
It is, but the key is that thin film of oil. A well-lubricated bearing really has almost zero metal-to-metal contact.
Wow.
That oil acts like a cushion, keeping those surfaces separated. And it's pretty remarkable when you think about the forces involved.
Yeah, it really is.
Yeah.
So speaking of oil, it's not just about reducing friction.
No, not at all.
It's like the multi-tool of the engine, right?
Absolutely. So, besides reducing friction, oil also cools. It draws heat away from those hot cylinders and pistons.
Okay.
Did you know that in some reciprocating engines, oil can handle up to 50% of the total cooling load?
50%. That's a lot more than I would have guessed.
It is. And then you also have the cleaning function. Oil picks up all those tiny little metal particles, combustion byproducts, carries them to the filter.
Right.
Keeps the engine from basically turning into a sludge pit.
And what about corrosion? The oil protects against that, too.
No, absolutely. A good oil film will protect those internal parts from rust and oxidation, especially important if an engine sits idle for a while.
Okay. So using the right oil.
Right.
And sticking to a regular maintenance schedule is super important.
Very important, yeah.
Okay. Let's talk about viscosity for a second.
Okay.
I hear a lot of mechanics throw that word around. But what does it really mean for us, you know?
So viscosity is basically a measure of how easily oil flows. Think about it like this. Honey has high viscosity. It's thick, flows slowly. Water has low viscosity. It's thin, flows easily. But the thing is, oil viscosity changes with temperature.
So on a cold day, the oil's like honey, and then on a hot day, it's more like water.
You got it. And that's why choosing the right oil viscosity is so important. You need an oil that's thin enough to flow easily when it's cold, but thick enough to provide that protection when things heat up.
So how do we choose the right viscosity for a particular engine? I see those numbers on the bottle, 10W30, you know?
All right.
What is all that about?
Yeah, that's the SAE viscosity scale. The W stands for winter.
Winter.
And that number before it tells you how well the oil flows at low temperatures. The lower the number, the better it flows when it's cold. The number after the W, that indicates the oil's viscosity at high temperatures.
Okay.
So it's kind of like...
So low numbers for cold starts?
Yep.
Higher numbers for when the engine's hot.
You got it. It's all about that balance between cold flow and high temperature protection. And, you know, we've come a long way from the old days of just straight mineral oils.
Yeah.
Now you got your ashless dispersant oils, your semi-synthetic oils.
Right.
That can handle a wider range of temperatures and just offer better performance.
Okay, so speaking of different types of oil, what's so special about those ashless dispersant oils?
Well, those old straight mineral oils, they tended to form sludge and deposits as they broke down.
Oh.
Not good. But ashless dispersant oils, they have additives that prevent those deposits from forming.
So they keep the engine cleaner.
Exactly. And they also have better anti-wear properties, and they can handle higher temperatures.
So how about the semi-synthetic oils? What's the advantage there?
Semi-synthetic oils are kind of a hybrid. You know, it's a blend of synthetic base oils and mineral oils. They give you the best of both worlds. They have even better viscosity characteristics than ashless dispersant oils, meaning they flow better when it's cold, provide better protection when it's hot.
Okay, so if they're so great, why not just use them all the time?
Well, you know they can be a bit pricier.
Right.
And for some engines, ashless dispersant oils are perfectly adequate. It really depends on the specific engine and what the manufacturer recommends.
Okay, so we talked about oil viscosity, different types of oil. Now let's talk about how that oil actually gets around the engine. I know there are different types of lubrication systems.
Right.
Like wet sump and dry sump.
Right.
What's the difference between those two?
So in a wet sump system, the oil is stored in a pan or sump at the bottom of the engine. And after it circulates through the engine, it drains back down into that sump.
So it's like a big oil bathtub inside the engine.
Pretty much, yeah.
Okay.
But wet sump systems have their limitations, especially in aircraft.
Oh, okay.
Imagine a plane doing a steep climb or a sharp bank.
Right.
All that oil could slosh to one side of the sump, and you could starve the engine of lubrication.
Oh, I see. I see the problem there. So that's where dry sump comes in.
Right.
Okay.
Dry sump systems use a separate tank to store the oil, usually mounted higher up on the engine. They also have multiple pumps. One to pressurize the oil and send it into the engine, and another one to scavenge the oil and return it back to the tank.
Okay, so even if the plane's upside down, that oil pump can still draw oil from the tank.
Exactly. That's why you typically see dry sump systems in aircraft, especially those that are designed for acrobatic maneuvers.
Makes sense.
High-G flight, things like that.
All right, so let's break down those dry sump systems a little bit more.
Sure.
What are the kind of key components we need to know about?
Well, you got your oil tank, which, like we said, stores the oil. It's usually made of aluminum, and it has to be pretty robust to handle the vibrations, G-forces, things like that.
And how much oil do these tanks typically hold?
Well, it varies. It depends on the aircraft, the engine.
Right.
But typically, it's enough to cover the entire fuel supply. And then you have some safety features built in, like vents, prevent pressure buildup, and a sump to collect any water or sediment that might get in there.
Okay. So you've got the tank. What's next in the oil's journey?
Next is the oil pump.
Good.
This is the heart of the dry sump system, responsible for pressurizing the oil, sending it through the engine. They're usually gear-type pumps. Pretty simple, but effective.
Gear-type pumps. So that's like two gears meshing together to force the oil through.
Exactly. They create positive displacement, meaning that for every rotation of the gears, a specific amount of oil is moved.
Okay.
Very reliable.
So the oil is pressurized by the pump, and then where does it go?
Well, not straight to the engine. First, it goes through an oil filter.
Of course, yeah.
To remove any contaminants. You know, we're talking tiny metal particles, combustion byproducts, anything that could cause wear and tear. You got different types of filters, screen filters, Kuno filters, spin-on filters, each with their own way of trapping those particles.
Okay. So it's kind of like the air filter in your car, but for oil.
Yep.
Got it.
Clean oil is happy oil. Then, after the filter, the oil goes through a pressure regulating valve, which makes sure that the oil pressure is just right.
So too much pressure is bad.
Yep.
Too little pressure is bad.
Right.
Got to find that sweet spot.
You nailed it. Too much pressure, and you risk blowing seals, damaging the lines. Too little pressure, and you might not get enough lubrication to those critical parts.
All right. So the oil has been filtered. The pressure is regulated. Where does it go next?
Well, in most aircraft engines, it takes a little detour through an oil cooler.
Of course.
Before it reaches its final destination.
Got to keep those temperatures in check. I'm guessing oil coolers for aircraft engines are a bit more sophisticated.
Oh, yeah.
Than what we see in cars.
They often have honeycomb core construction for maximum heat transfer efficiency.
Wow.
And they also have a bypass mechanism, so cold oil can bypass the cooler until it warms up.
Clever. So the oil cooler makes sure the oil's at that perfect temperature before it finally gets into the engine.
Right. And from there, it's delivered to all those critical parts, bearings, gears, camshafts, you name it, anything that needs a good dose of lubrication.
All right. So we've followed that oil's journey from the tank through the pump, the filter, the pressure regulator, the cooler, and finally to the engine itself. But how do we know all this is actually working? How it should be? Are there any gauges?
Yeah.
Indicators to keep an eye on things?
Absolutely. You've got your oil pressure gauge, which tells you the pressure in the system, obviously. And then you've got your oil temperature gauge, which monitors the oil temp. Those are your primary indicators of oil system health.
Okay. And what about those magnetic chip detectors I've heard about? Are those standard on most aircraft engines?
They're becoming increasingly common, especially on turbine engines. Okay. They're basically little magnets strategically placed in the oil flow path that trap any metallic debris that might be circulating in the oil.
So they're like an early warning system for engine wear.
Exactly. By inspecting those chip detectors regularly, you can often spot potential problems before they become big problems.
Okay, so we've covered the basics of dry sump systems, but I know you have a ton of experience with turbine engines. What are some of the things that make lubricating those high-performance beasts unique?
Turbine engines, those are a whole other animal.
Yeah.
There's incredible speeds, scorching temperatures. They really demand a lot from their lubrication systems.
What sets them apart? What do we need to keep in mind?
Well, first of all, you're not going to be using your typical mineral-based oil in a turbine engine.
Right.
They require special synthetic oils that can handle those extreme conditions.
So it's like high-performance oil for a high-performance engine.
Exactly. And because of the intense heat, oil cooling is even more crucial in turbine engines.
Yeah, okay.
Mm-hmm.
We talked about oil coolers earlier, but are there any special considerations for turbine engines? I mean, they generate a lot of heat, right?
Oh, they do. They often use a combination of air-cooled and fuel-cooled oil coolers to keep those temps in check.
So they're using both air and defuel to keep the oil cool.
Yep.
That's pretty ingenious.
It is. And then there's the issue of maintaining proper oil spray patterns
Okay.
in those intricate turbine engine bearings.
Oil spray patterns. What's that all about?
It's all about precision.
Okay.
The oil is sprayed onto the bearings through these carefully positioned jets. And those spray patterns need to be just right to make sure those bearings are getting the right amount of lubrication and coolant.
So if that spray pattern gets messed up, you're in trouble.
Oh, absolutely. You can have a hot bearing, premature wear, even bearing failure.
Not good.
Yeah.
So how do they make sure that those spray patterns stay consistent, especially with all those high-speed, rotating parts?
Well, that's where what's called a breather pressurization system comes in.
Okay.
It sounds complicated, but it's basically a system of vents and valves that regulate the air pressure within the engine's oil system. And that helps maintain those oil flow and spray patterns.
So it's like a mini air traffic control system for the oil.
I like that, yeah.
Keeping things moving where they need to go.
Mm-hmm.
So we talked about those magnetic chip detectors earlier.
Right.
I know they're very common in turbine engines.
Yep.
But why are they so important in these high-performance applications?
Well, those turbine engines operate at such high speeds and temperatures that even the tiniest bit of wear can quickly become a big problem.
So early detection is key.
Exactly. Those chip detectors are like little detectives,
Mm-hmm.
constantly on the lookout for clues that something might be wrong. And trust me, catching those problems early can save you a lot of time, money, and headaches.
Makes sense. Now, I know we've talked a lot about pressure lubrication, but I've heard that turbine engines also use what's called splash lubrication.
Right.
What is that? Are we just splashing oil around inside the engine?
Not quite as chaotic as it sounds. Think about those high-speed shafts spinning inside the turbine engine. They're rotating at thousands of RPM.
Wow.
And that creates a sort of oil mist or fog inside the engine casing. And that oil mist helps lubricate components that aren't directly fed by those pressurized oil jets.
So it's like a self-lubricating system in a way. The spinning parts are kind of creating their own lubrication.
Precisely. And this combination of pressure lubrication and splash lubrication ensures that all those critical parts, from bearings to gears to seals, stay lubricated even under those extreme conditions.
That's amazing. What about those massive turbine blades?
Yeah.
Those are exposed to incredible heat and forces. How do they stay lubricated?
Those turbine blades are kind of a special case.
Right.
They don't rely on traditional oil lubrication.
Right.
Instead, they're cooled from the inside out.
Cooled from the inside out. What does that even mean? Do they have like tiny little oil coolers in each blade?
Not quite. Many turbine blades are actually hollow.
Oh, okay.
And air is bled from the compressor stages and channeled through those internal passages. And that helps keep the blades from overheating, which is crucial for their strength and performance.
So it's like internal air conditioning for the blades.
You got it.
That's pretty ingenious.
It is.
Speaking of ingenuity, what about the future of aircraft lubrication? Anything new and exciting on the horizon?
There's always something new cooking in the world of lubrication. One area that's really exciting is bio-based oils.
Bio-based oils? What are those all about?
These oils are made from renewable sources like plants and vegetables.
Wow.
Imagine that. Lubricating your engine with something that you could practically grow in your backyard.
So we're talking like going green with our engine oil.
Exactly.
Okay.
Bio-based oils have the potential to be much more environmentally friendly and sustainable than traditional petroleum-based oil.
That's fantastic. Anything else cool in the works?
Another area that's really showing a lot of promise is nanolubricants.
Nanolubricants.
Yeah. These lubricants use tiny particles called nanoparticles to reduce friction and wear at a molecular level.
Nanolubricants. That sounds like something straight out of Star Trek.
It kind of does, doesn't it?
Yeah.
But the potential benefits are real. Nanolubricants could lead to longer engine life, improved fuel efficiency, reduced emissions, It's definitely an area to keep an eye on.
It sounds like the future of aircraft lubrication is going to be very exciting.
Oh, it definitely is. It's a field that's constantly innovating, always striving for better performance, efficiency, and sustainability.
Well, I think we've covered a lot of ground here today. We've talked about the different types of oil, how those lubrication systems work, the importance of cooling, and even some of the really cutting-edge developments that are shaping the future of this really vital field.
Absolutely.
I feel like I've learned a ton.
Me too. It's been a great discussion.
Yeah, it really has.
And remember, whether you're working on a small piston engine or a massive turbine, a well-maintained lubrication system is key to keeping those engines running smooth and reliably.
Couldn't have said it better myself. So keep those engines lubricated, and we'll catch you next time for another deep dive into the fascinating world of aviation.
You know, we've talked about oil, but what about the parts it's protecting?
Okay.
Bearings. They're like the unsung heroes of any engine. And there's a surprising variety of them.
Yeah, bearings. I know they're important. I haven't given them a whole lot of thought, to be honest.
Well, there's a lot more to it than just, slapping some grease on them.
Right.
You got your plain bearings, ball bearings, roller bearings, each one designed for different loads and speeds.
Let's break it down. What are plain bearings, and where would you find those in an engine?
Plain bearings, they're the simplest type. Think of a shaft rotating inside a sleeve, and the oil forms that thin film between them, preventing that metal-to-metal contact. They're tough, they can handle heavy loads, but they need a constant oil supply under pressure.
So they're like the workhorses of the bearing world.
Yeah, pretty much.
Where are they usually found?
Crankshaft bearings, connecting rod bearings, camshaft bearings, basically anywhere you have high loads and relatively slow speeds.
Okay, so plain bearings for the heavy lifting. What about those ball bearings? Those seem pretty common in all sorts of machinery.
Yeah. Ball bearings, they're all about reducing friction. So instead of sliding contact, they use these tiny hardened steel balls that roll between an inner race and an outer race.
Okay.
And that rolling motion, it requires less lubrication than sliding friction, and it can handle higher speeds.
So less friction means less wear and tear.
Right.
And they can spin faster. Sounds like a win-win. Where do those guys usually hang out in an engine?
You'll find them in all sorts of accessory drives, like magnetos, generators, fuel pumps. Even in some engine control systems, they're pretty versatile.
Okay, so we got plain bearings for heavy loads.
Right.
Ball bearings for speed.
Right.
What about roller bearings? Where do they fit in?
Roller bearings are similar to ball bearings, but they use cylindrical rollers instead of balls. This gives them even more load-carrying capacity. And they can handle those side-to-side forces really well.
So roller bearings are the heavy-duty champions.
Yeah.
Of the bearing world.
Yeah, I guess you could say that.
Where would you find those putting in the hard work?
I think wheel bearings.
Oh, okay.
Where they're supporting the weight of the aircraft, dealing with all those bumps and turns.
Right.
You'll also find them in some high-load gearboxes and transmission systems.
Okay, so we got our plain bearings, ball bearings, and roller bearings all doing their part to keep things running smoothly. But I'm curious, when we talk about different types of oil, like the ashless dispersant oils, semi-synthetic oils, are there specific types of bearings that work best with certain types of oil?
That's a great question.
Yeah.
The type of oil you use can definitely have an impact on bearing life and performance. For example, those ashless dispersant oils we talked about, they're really good at keeping bearings clean, preventing sludge buildup.
So they're like the cleaning crew for the bearings.
Yep. And because they have those better anti-wear properties, they can actually help extend bearing life.
And how about those semi-synthetics? Do those offer any advantages for bearings?
Semi-synthetic oils, they're great all-around performers. They have excellent viscosity characteristics, meaning they flow well when it's cold, provide good protection at high temperatures.
Right.
That can be especially beneficial for bearings that operate over a wide temperature range.
So they're like the multi-grade oil of the bearing world.
Yeah, I like that.
Good for all seasons.
But ultimately, the best oil for any particular bearing is going to depend on the specific type of bearing, the operating conditions, and of course, what the manufacturer recommends.
Right. Always got to check the manual.
Yeah.
Now, we've talked a lot about dry sump systems, how they're great for aircraft. But how did those systems even come about? Were they always designed for planes?
Not at all.
Oh.
Dry sump lubrication was originally developed for high-performance racing cars and motorcycles.
Really? So they were born on the racetrack.
Yeah. Yep. It was all about keeping the oil flowing under those extreme G-forces, preventing oil starvation, during hard cornering and acceleration.
And then somebody was like, hey, this would be great for airplanes too.
Exactly. Same principles apply.
Right.
High-performance aircraft, you're dealing with similar G-forces, acrobatic maneuvers, the need for a reliable oil supply no matter what you're doing in the air.
Makes sense. So what are some of the key advantages that make dry sump systems so well suited for aviation? We talked about the oil control during those high G maneuvers, but what else makes them so great?
Well, one big advantage is improved oil cooling.
Yep.
Because the oil is stored in that separate tank, it has more time, more surface area to cool down before being recirculated.
So it's like giving the oil a little break.
Yeah.
A chance to chill out.
Exactly.
Before it goes back into the heat of battle.
And that cooler oil means better lubrication, reduced wear and tear, happier engine.
And I imagine that separate oil tank also lets you carry more oil, right? It's kind of like having an extra fuel tank for your lubrication system.
You got it. That increased oil capacity is especially important for longer flights or aircraft that operate in demanded environments.
So it's that combination of the oil control, the better cooling, increased oil capacity. That makes dry sump systems the go-to choice for a lot of aircraft.
Absolutely. It's a testament to how engineering advancements in one field can be adapted for another to meet very specific needs.
All right, so we've established dry sump systems are pretty awesome. But let's get a little deeper into the nuts and bolts. We've talked about the oil tank, the pumps. What about those filters? What types of filters do you typically find in a dry sump system, and how do they work their magic?
Just like in wet sump systems, you'll find a variety of filter types. In a dry sump system, some of the most common ones are screen filters, Kuno filters, and the trusty spin-on filters.
Okay, let's start with the screen filters. Those sound pretty basic. How do they actually filter the oil?
Screen filters are the simplest type. It's basically a fine mesh screen that traps particles as the oil flows through. Think of it like a sieve.
Okay, so they catch the big chunks.
Right.
What about those tiny little particles that can still cause wear and tear?
Yeah, you're right. They're not that effective at trapping those microscopic particles. That's where those other filter types come in.
Got it. Where are those screen filters typically located?
They're often used as suction filters, so they're positioned right at the inlet of the oil pump.
Okay.
And that prevents debris from entering the pump itself and causing damage.
Okay, so screen filters, kind of a first line of defense, protecting that pump. What about those Kuno filters? Those sound a little more high-tech.
Kuno filters, those are definitely more sophisticated. They use a stack of closely spaced discs with a clean-in blade that rotates between them.
So how does that actually clean the oil?
As the oil flows through the spaces between those discs, any particles, they get trapped on the disc surfaces.
Okay.
And then that cleaning blade comes along, scrapes those particles off, keeps the filter element nice and clean.
So it's like a self-clean-in filter.
Pretty much, yeah.
Less maintenance.
Yep. Kuno filters are known for their efficiency and their ability to handle those high flow rates, which makes them suitable for some aircraft applications.
All right, and last but not least, we have those spin-on filters.
Right.
Those are pretty common in cars.
Yep.
Do we see those a lot in aircrafts too?
Yeah, you see them a lot, especially in smaller reciprocating engines, becoming increasingly popular because they're just so convenient and they're really effective.
Yeah, they're easy to change.
Yeah.
Why are they so good at filtering the oil, though? What's the secret sauce?
They typically use a pleated paper element that provides a large surface area to trap those contaminants.
Okay.
And most of them have a built-in bypass valve, which is a nice safety feature.
What does that bypass valve do?
It's basically an insurance policy for your engine. If that filter element gets clogged, that bypass valve opens up and allows the oil to flow around the filter, and that prevents oil starvation to the engine, which could cause some serious damage.
So it's kind of like a pressure relief valve for the oil filter.
Exactly. And because spin-on filters are self-contained units, they're really easy to service. Just spin off the old one, spin on a new one.
So we got our screen filters, our Kuno filters, and our spin-ons, each one with its own way of keeping that oil clean.
Right.
But once the oil has been filtered, where does it go next?
Well, in most cases, after the oil passes through the filter, it's time for a cool down. It's off to the oil cooler.
Right, the Aura cooler. We've talked about them, but why are they so essential in a dry sump system? It's not like the oil's getting that hot, just hanging out in the tank.
That's true. But remember that oil is constantly being circulated through the engine, picking up a lot of heat. And in a dry sump system where you've got those multiple pumps and that higher flow rate, that oil cooler becomes even more important.
So it's like a radiator for the oil.
Yep.
Keeping those temperatures down and preventing the oil from breaking down.
Exactly. Maintaining the right oil temperature is essential for good lubrication, engine longevity, the whole 9 yards.
Okay, so the oil cooler keeps the oil from getting too hot. What happens after it's cooled down?
From the oil cooler, the oil flows through the pressure regulating valve, which we talked about earlier.
Right.
That little guy makes sure the oil pressure stays within that, sweet spot. Not too high, not too low.
Right. Got to find that Goldilocks zone for your oil pressure.
You got it.
And then finally, after all that, filtering and cooling and regulative, the oil is finally ready to be delivered to the engine.
It is. From the pressure regulating valve, the oil is finally ready to do its job. It flows through a series of oil passages and jets, delivering a precise spray of oil to all those critical components. Bearings, gears, camshafts, you name it.
So it's a long and winding road for that oil.
It is.
But ultimately, it all comes down to keeping those engines running smooth.
That's right. It's a fascinating system. Understanding how it works can make you a better mechanic.
Right.
And a more informed pilot.
Speaking of understanding how things work, we've talked a lot about reciprocating engines,
Right.
dry sump systems. I know you're kind of a turbine engine guru.
I dabble.
Can you give us a little bit more of a deep dive into the lubrication specifics for turbine engines?
Yeah, sure. Turbine engines, they're incredible machines.
Yeah.
Incredible speeds, scorching temperatures.
Right.
They have some unique lubrication requirements that really set them apart.
So what are some of the things that make lubricating these high-performance beasts so different?
Well, for starters, you can forget about your typical mineral-based oil.
Okay.
Turbine engines need specialized synthetic oils that can handle those extreme temperatures, pressures.
So it's like using high-performance oil for a high-performance engine.
Exactly. And because of the intense heat that's generated by those spin-in turbines, oil cooling becomes even more critical.
Okay, we've talked about oil coolers.
Right.
But I'm guessing the oil coolers in a turbine engine are even more heavy-duty.
Oh, you better believe it. They often use a combination of air-cooled and fuel-cooled oil coolers.
Wow.
To keep those temperatures in check.
So they're using both air and fuel to keep that oil cool.
Yep. It's a sophisticated system designed to handle, immense heat loads.
That's impressive.
It is. And then you have the challenge of maintaining those precise oil spray patterns.
Right.
In those intricate turbine engine bearings.
Right. We talked about oil spray patterns, but why are those so critical in turbine engines? Is it just because those bearings are spinning so fast?
It's more than just the speed. The oil spray patterns in a turbine engine need to be meticulously engineered to make sure those bearings are getting the exact amount of lubrication and cooling they need.
Okay.
To survive in that extreme environment.
So if that spray pattern gets disrupted, you could end up with a hot bearing.
Right.
Premature wear.
Yep.
Potentially even engine failure.
Exactly. Maintaining those spray patterns is absolutely crucial.
Okay. So how do they ensure that those spray patterns stay consistent, especially with all those high-speed rotating parts and the extreme temperatures?
Well, that's where the breather pressurization system comes in.
Right.
Sounds complicated, but it's basically a system of vents and valves that regulate the air pressure within the engine's oil system.
Okay.
And this helps maintain that consistent oil flow and those critical spray patterns.
So it's like a mini air traffic control for the oil.
I like that. Yeah, that's a good way to put it.
Making sure that the oil is getting to where it needs to go at the right time, the right amount.
Right.
And we talked about those magnetic chip detectors earlier, and they're really common in turbine engines. But why are those so essential in these high-performance applications? Is it just because the stakes are higher?
Well, that's definitely part of it. But you got to remember, those turbine engines operate at such high speeds and temperatures that even the tiniest bit of wear can quickly escalate into a major problem.
So it's all about early detection and prevention.
Exactly. Those chip detectors are like tiny little sentinels,
Mm-hmm.
constantly monitoring the oil for any signs of metallic debris could indicate wear or damage. And trust me, catching those problems early can save a lot of, headaches and expensive repairs down the road.
Now, I know we talked a lot about pressure lubrication.
Yeah.
But I've also heard that turbine engines use what's called splash lubrication. What's that all about? Are we just splashing oil around inside the engine?
It's not quite as messy as it sounds. Think about those massive shafts spinning inside a turbine engine, rotating at thousands of RPM.
Wow.
And as they spin, they create this fine oil mist, almost like a fog inside the engine casing. And that oil mist, it helps lubricate components that aren't directly fed by those pressurized oil jets.
So it's kind of like a self-lubricating system, in a way? Those spin-in parts are creating their own lubrication.
Precisely. And this combination of pressure lubrication and splash lubrication, it just ensures that everything stays lubricated, even in those extreme operating conditions.
That's incredible. But what about those massive turbine blades themselves? They're exposed to some of the highest temperatures and forces in the entire engine. How do they stay lubricated?
You're right. Those turbine blades are a special case. They don't rely on traditional oil lubrication like the other components. Instead, they're cooled from the inside out.
Cooled from the inside out. What does that even mean? Do they have tiny little oil coolers in each blade?
No, not quite. Many turbine blades are actually hollow.
Okay.
And air is bled from the compressor stages and channeled through these internal passages.
Okay.
And that helps keep the blades from overheating, which is crucial for their structural integrity and performance.
So it's like internal air conditioning for the blades.
Yep.
Pretty ingenious.
It is.
Speaking of ingenuity, I'm curious about the future of aircraft lubrication.
Yeah.
What's on the horizon? Any new technologies?
Mm.
Developments?
Yeah.
That could change the way we keep these engines running smooth.
Oh, yeah. There's always something new happening in the world of lubrication. One area that's really promising is bio-based oils.
Bio-based oils. Okay, what are those all about? Are we talking putting olive oil in our engines now?
Not quite olive oil, but you're on the right track. These bio-based oils are made from renewable sources, like plants and vegetables.
Wow.
Imagine that. Lubricating your engine with something that you could practically grow in your backyard.
So we're talking going green with our engine oil.
Exactly. Bio-based oils have the potential to be much more environmentally friendly, sustainable than traditional petroleum-based oils.
That's fantastic. Any other groundbreaking technologies on the horizon?
Another area that's really exciting is nanolubricants.
Nanolubricants.
Yeah. These lubricants use incredibly tiny particles, called nanoparticles, to reduce friction and wear at the molecular level.
Nanolubricants? That sounds like something straight out of Star Trek. Are we talking about microscopic robots lubricating our engines?
It's not quite robots, but it's definitely high-tech.
Yeah.
The idea is that these nanoparticles can create an ultra-thin, super slippery layer between moving parts, and that can dramatically reduce friction and wear.
Wow, that's amazing.
Yeah, it's a fascinating field.
Sounds like the future of aircraft lubrication is pretty exciting.
Oh, it definitely is. It's a field that's constantly innovating, always pushing the boundaries of what's possible.
All right, so we've covered a lot of ground here today. We've talked about the different types of oil, the lubrication systems, talked about the importance of coolant, filtration, and even some of the cutting-edge developments that are shaping the future of this, vital field.
It is. It's the lifeblood of any aircraft engine.
Yeah, absolutely. I feel like I could give a seminar on this stuff now.
Me too. It's been a great discussion.
It has.
And I think the big takeaway here is that whether you're a pilot, you're a mechanic, or just an aviation enthusiast, understanding how these systems work is really key to appreciating these incredible machines.
Well said. So, folks, keep those engines lubricated, stay curious, and we'll catch you next time on The Deep Dive for another deep dive into the fascinating world of aviation.
We've been talking a lot about the theory and the inner workings of lubrication systems.
Right.
But let's get practical for a minute.
Okay.
Imagine you're a pilot, you're doing your pre-flight.
Okay.
What are some things you can look for to get a sense of your lubrication system's health?
Yeah, that's a good point. I mean, I might not be rebuilding engines every day, but as a pilot, I definitely want to make sure things are good before I, take to the skies.
Absolutely. And you don't need to be a mechanic to spot some potential red flags.
Okay.
First off, just take a walk around the aircraft. Look for any signs of oil leaks.
Okay.
Check around the engine cowling, under the engine itself, anywhere where those oil lines might be running.
Okay. Leaks are bad. What else?
Pop open that cowling. Take a look at the oil level in the tank. Most aircraft have dipsticks or sight gauges that make that a pretty easy check.
Right.
Make sure the level's within the specified range.
Right. Got to have enough oil to keep things running smooth.
Exactly. And while you're there, take a look at the oil's condition. Fresh oil should be clear, relatively light in color.
Okay.
If it's dark, murky, has kind of a gritty texture, that's a sign that it's contaminated. It needs to be changed.
So like checking the color and consistency of your engine's blood.
Yeah.
Healthy blood, healthy engine.
Exactly. And if you've got those magnetic chip detectors, take a peek at those.
Right.
Excessive amount of metal debris could be a sign of trouble brewing.
Okay, check for leaks, check the oil level and condition, inspect those chip detectors, anything else a pilot can do during that pre-flight.
One more thing, especially if it's a cold day, make sure that oil has had a chance to warm up. Cold oil is thick, doesn't flow as easily. That can put extra strain on the system during startup.
Right, so just like I need to stretch my muscles before I go for a run, that oil needs a little warm up too.
Exactly.
All right.
And lastly, just remember, your senses are your best allies.
Okay.
See something unusual, smell something, hear something, don't ignore it. Better to be safe than sorry. Have a qualified mechanic take a look.
Solid advice.
Mm-hmm.
Well, I think we've covered just about everything there is to know about aircraft lubrication. We've explored the different types of oil, gone deep into the lubrication systems themselves. We've talked about the importance of coolant and filtration, and even touched on some of those cutting-edge developments that are really shaping the future of this, vital field.
Absolutely. It's been a great discussion.
It really has.
And I think the big takeaway here is that a well-maintained lubrication system is the heart of any aircraft engine. And whether you're a pilot, a mechanic, or just an aviation enthusiast, understanding how these systems work is really key to appreciating these incredible machines that keep us in the air.
Well said. So keep those engines lubricated, stay curious, and we'll catch you next time.